Well, hello, this is Nitin Dahad of EE Times, and I'm here at the final day of the Embedded World conference in Nuremberg in Germany, and talking to my very good friend, Jim McGregor of TIRIAS Research. Jim, hello, how are you?
Good. It's been an exciting show.
It certainly has, and compared to CES, this is a totally different level for me. It's kind of like the deep foundational tech, whereas CES was like, oh, all these humanoid robots. But
Yeah, and instead of having the massive focus on like TVs and this and that, you've got thousands of companies in a very small area. I describe it as being it's like speed dating on steroids, because I mean every 30 minutes you can meet with a company and you still never meet with. I mean, in 3 days, I think I've met with probably 60 companies, and that's still not enough.
Yeah. You know, one of the things that struck me, and ARM has always talked about ecosystems.
Yes.
And this is an ecosystem, yeah, right from the hardware to the tool chains, software, and all layers of the stack. And this is where I think you find everybody, and it's become the established show for that, hasn't it?
Oh, absolutely. You know, it is amazing because you've got chip vendors, you've got the board vendors, you've got the systems vendors, you've got the software vendors, the tool vendors. It is incredible to see the level, and you see a lot of innovation. Obviously, we expected a lot of robotics this year, but yeah, it's everywhere. Everywhere you look, there's something tied to robotics, whether it's the motor, it's the semiconductors, it's the systems.
No, the difference is on CES show floor, you'd actually see the humanoid robots. What you're seeing here is the actuators, the little fingers, little industrial arms. So I think it's very different. People are looking at, okay, what can we do with it, as opposed to just this sci-fi stuff.
Exactly.
Yeah. So now coming to like some of the trends, I think, again, as I expected, it's edge AI, but the new word for that is physical AI, and then
Physical
you've got
AI.
Humanoid robotics. But I think there's a new I saw the companies like NXP, Synaptics, Silicon Labs, and then Micron memory, and then some of the security guys. It seems like everybody's trying to enable this edge AI and physical AI and go for this market, and putting different variants of microcontroller or MCU, connectivity, and the accelerator.
Oh yeah, where it's
Different combinations.
Well, it's kind of funny because it's what IoT was supposed to be originally.
Yeah.
But not only are they trying to do that, but they're trying to run AI on them. In a lot of cases, we're seeing these microcontrollers. They're running at sub-threshold voltages. They're running less than a watt and still running AI workloads. That's impressive, and agentic AI workloads. That's very impressive.
Yeah, I mean, I still have got this stuck in my mind. I saw Deepex and Lokwon Kim, who's like a really effusive, I'm going to do this, I'm going to do this in the world, very ambitious. And he's talking about putting 100 billion parameters on a chip, less than 5 watts. And last year he did the butter test, and said it'll still be the same, it won't melt the butter.
It's a good example.
Yeah, but no, I mean, I'm guessing you've seen lots of that kind of deployment.
Very much so.
So what's the key trend for you from TIRIAS?
The key trend is, one, we're seeing, I think, a lot of these systems grow up. So, I mean, typically when you thought about a microcontroller or some of these embedded processors, they were on older process nodes. So we're seeing some of them move to the latest process nodes.
Yeah.
We saw that with Ambarella being on 4 nanometer for an embedded SoC. That's incredible. They're integrating more into them. You look at some of the stuff from Synaptics. They have the latest wireless technology with Bluetooth 6.0 and with Wi-Fi 7.
Yeah.
And in addition to everything they're doing on the silicon side, they're trying to wrap tools and AI tools around them. So they're trying to make it easier for any developer to basically, take these platforms, do layouts, find different parts, and basically architect a system as quickly as possible.
Yeah, and that is something I'm seeing a lot. I mean, 2 or 3 years ago, I saw companies like Celis and providing this AI tool to do the. But now you're seeing everybody provide these tools to get to market faster, basically, using commercial terms. But it literally is doing things in minutes, weeks, hours, weeks, isn't it, compared to 6 months or a year?
It is. The only one concern here is the fact that each company is doing their own.
Yeah.
So unless you're working with something like, Synaptics has their products, their SL 2600 actually uses like the Google Coral NPU.
Yeah.
So unless you have that kind of open source mentality and that open source solution, you've got a bunch of distinct tools for each platform. I'm not saying it's not helpful, it is.
Yeah.
But it's still going to be hard for developers when they're saying, well, I may need a part from this company, and a part from this company, and a part from this company, and the tools don't necessarily go across.
Yeah, that was kind of something when I spoke to Renesas this morning with their new Altium
Yes.
365 online. The question I had in my mind is, okay, it's obviously for their products.
Yes.
And one of the things I think Rahul Patel of Synaptics said was, we're trying to democratize AI. And I think that's a message I'm getting from everybody. High levels of abstraction, enabling people to then deploy models. And there were several companies that I've spoken to that are trying to do that.
Yes.
So I think it's still company specific. And if you look back to our embedded surveys, the Aspen Core Media embedded surveys, one of the things about the minds of the embedded engineer is basically they're already used to one tool chain or one processor, so they're going to go for that anyway. So for example, if they're Renesas or if they're TI,
That's true.
So I think that's a decision already made. I'm not sure there's anything out there at the moment that will say, well, look, you can choose from this whole vast array.
Well, and I think a big differentiator is going to be is those companies that can integrate these tool chains, not just all their tools, because a lot of times companies acquire companies, so you see tools from different entities within the same company. But and Renesas is a good example. They've kind of created a single interface for all the tools. ADI has done that. Some other companies have done that. But I think it's also going to be interesting to see how they can integrate these tools and have them work seamlessly with the EDA tools from Cadence, Synopsys, and Siemens. Because eventually you have to go from that, that concept design to a board level and system design.
Yeah, that's exactly what I asked Renesas this morning. And like all corporate presentations are like, okay, well, the engineer will then decide what to do.
Well, the engineer's going to be AI pretty soon, so.
Well, that's what we're told. The other thing I think I got very much from this show is everyone's been talking about AI agents, but what I realized is you're not going to get generalized AI agents for certain things, and you're getting task-specific, which is really going to change things. The more general ones, it's a bit more difficult. I mean, I saw, what's the name, Exmos with the new interface, which is you can use OpenAI or Claude or Anthropic, anybody, to design, say for example, a karaoke block, but only use your voice in certain parts.
Yes.
And it's all generated through a block, and then you get the block diagram, and then you can go down to putting that the processor array. So that's quite fascinating in terms of being able to do that.
It is, and it's funny because one of the things I keep wondering as I'm walking around here is what does a PC look like in 5 years, and what does all these other applications? We've had for quite some time, for a decade or more, we've actually had audio interfaces and stuff like that, but they haven't been that good.
Yeah.
Now they're good,
yeah.
and as you pointed out, they're usually very application specific, and they can run on very low power solutions. And I'm just like, I'm really wondering, with the advanced sensor technology, with the agentic software, with the capabilities of running these almost anywhere, anytime, we're going to be living in a world where we're going to be surrounded by agents that are very easy to talk to. Yeah. I mean, even in your PC, I can't. If I'm actually using a keyboard on the PC in 5 years, I think I'm going to be amazed.
The other thing I saw, there's three things. There's RISC-V, there's memory, and there's security.
Yes.
Let's focus on security, but just touch the other ones quickly. RISC-V, I mean, you see it in all the designs everywhere. So
yes.
It's not as if it's one of these fancy technologies I'm seeing. Like, for example, Exmos, the newest is it N400? I'm not sure, but check the numbers. But it's a RISC-V based processor array. But you see it everywhere, and I think.
Oh, you do. There's not a single processor produced by Intel or Qualcomm or a lot of these companies that doesn't have a RISC-V MCU core already integrated for a specific function.
Yes.
But yeah, at this show, I definitely think you see that whole RISC-V ecosystem coming up with a lot with MIPS and TensTorrent and Sci5 and all these guys.
I spoke to Samir Wasson at MIPS and Global Foundries MIPS now. It's fascinating, like now they're tied into the Global Foundries, GF.
Yes.
Just how they can tweak things like PDKs and stuff like that, to suit certain physical AI applications. But their processor, their RISC, their ARC, that's that whole value chain, as it were.
Very much so, and it's well suited. And, they don't have to be on the latest process node, especially for these applications. In a lot of cases, sometimes even I kind of laugh because sometimes you're creating a chip so small that you can't cut it.
Yeah. Okay, quick on memory. I know the big talk, if you look from the distribution side, obviously this is a big distribution show as well. Like shortage, allocation, all go to data centers, but I spoke to Micron, they said, well, they're focused on automotive especially, so they've got allocation there, but others you talk to, it's otherwise.
It is otherwise, and let's face it, if you're not on the top of the food chain, which right now is pretty much NVIDIA, if you're not on the top of the food chain, you don't have allocation, and that's going to be a huge challenge for everyone. I even at CES, seeing all the startups there, I was really worried because a lot of the startups, these device and system startups, are not going to be able to get allocation. Even if they could, it's going to be so expensive that it's going to price them out of the market. It's going to be, not only is it going to limit our growth as an industry throughout 2026 and possibly 2027, but it's definitely going to have a huge impact on what we see and how quickly some of these devices come to market.
Now, just a little section. Sorry, go ahead.
Well, I was also going to say, and these guys are so desperate, they're actually going to their chipset or their technology providers and saying, "Can you help us get memory?" And unfortunately, they're like, "We're not a memory vendor."
Yeah. But I mean, I've heard also that it's going to come to some point where it's just going to into a glut again, and we're going to that cycle again. Yeah.
The question is when. I think that's 2028 maybe or 2029, but that's a ways out.
Yeah. Finally, security.
We
can't go anywhere in Europe without CRA being mentioned. But the other angle, I've spoken to people like SCI Semiconductor, but Cherry as well about memory safety. It's a big thing. Some people are saying, spoke to Dan Cooley at Silicon Labs, customers are really switched on to security.
Yeah.
There's other people who are saying, well, it's still a hard sell.
Well, and I think part of that is it depends on what you're selling into. Yeah. I think a lot of these platforms, especially when we think of robotics or automation, stuff like this, the platform is more than just a single system. It's the network. It's multiple different devices. So as you start thinking about that, you have to think of that data is not just going to be on one machine. It's going to be transferring throughout this workload flow, and that becomes a challenge. And you're right. I've even had microcontroller vendors start talking about quantum safe security. Yeah. That blows me away.
Yeah. I mean, NXP is a good example where they're talking about, we were putting the PQC standards involved in that, and it's coming through in some of our products. What's been the key, we've already talked about takeaways, but what's been the real highlight for you? One thing.
If I had to pick one thing, I would say that I'm kind of, it's robotics, and I'm going to come back to robotics, not just because it's the hot topic of the day, but also the fact that people are really taking a detailed look at it, and you see it here at the show. Yeah. You mentioned it earlier, it's not just about robots kind of scanning the floor like at CES, it's about looking at how robots work. And a robot, especially a humanoid robot, has to act and operate like a human. So it's not just going to have this high, powerful brain to do all the processing and LLMs and everything else. It has to have, controllers in the hand to be able to have touch and temperature sensors and everything else. It basically has to have a nervous system throughout its core, and it has to act like a nervous system. So from the servos to motor control to the sensors to everything, we're seeing that innovation come through. To actually make humanoids kind of real.
Yeah. I mean, for me, it's kind of like the level of integration that's happening just to enable this edge AI and physical AI. And for example, this morning I saw at Wind River, Aptiv Wind River, a integrated ultrasound plus camera they've taken some of the stuff from automotive, putting it into industrial, the point clouds to map the sensors. And that's quite fascinating how that level of integration.
Well, and you get the definite feel here that everyone, there was such a big focus a couple of years ago on autonomous vehicles, which, have been a challenge, but everyone's trying to leverage all that entire technology stack to move into robotics, and not just humanoids, but industrial robots, materials handling, production, any type of robotic type of, or autonomous machines, I should say.
Yeah, I mean, and just close on the integration. I spoke to the CTO of the group for Trio for onsemi. Like the level of integration there on their processes, for the high voltage, 70, 90 volts, down to CMOS. On one piece of silicon, and obviously this is kind of well documented, but this is fascinating how they can isolate all of that, and
yes,
which goes back to the deep trench and whatever isolation semiconductors. But I find that fascinating that it's all finding a use now.
Oh yeah, very much so, very much so, and even seeing microcontrollers that are on gate-all-around technology, that kind of blows me away.
Yeah.
I mean, we're seeing. I think if anything else, we're seeing how quickly the technology is advancing throughout the ecosystem.
Yeah. Well, Jim McGregor, it's been lovely talking to you, and hopefully you'll get home. So one of the.
My flight got canceled on Lufthansa. Thank you very much, Lufthansa, for that.
Yeah. But the really fun thing here, I guess, and I think I put it on my LinkedIn post earlier this week, is like. There was an email to all attendees on Monday night saying there's an aerial bomb discovered, so it's going to close from 9 a.m. So get there before.
Yes,
because we're going to defuse it. So everybody is rushed to get here before, and
only in Europe.
Only in Germany.
It was actually, I guess, a World War II bomb.
It was,
that they found when they were digging up a foundation for a new building or something.
Yeah.
So always something interesting.
But it's always fun.
Yes, it is.
Well, till next time, Jim, thank you very much.
Thank you.
Thank you.